we are using different types of regression algorithms. So when I say regression, I'm referring to a target variable that I'm trying to predict, which is continuous. When it comes to classification, I'm referring to discrete variables. Discrete variable 0, 1. Yes, no. So I would like to predict if this student is going to pass or fail from my class. So for that, I'm going to be using classification. I'm going to divide students into two groups. Those who are passing and those who are failing. So I'm going to talk about these two, classification and regression, again in this meeting. Now, based on the information we collect from the data set, we develop a model, we train that model, and we generalize our result. So what is that? I know about the students who took machine learning class before. I know their grades. I know, let's say, their other activities, their other grades, let's say. And I set up a model. As I said, a student getting a high grade from data analytics with Python class, which is a different class, most likely will get an A from my class. That's a strong predictor of the student's grade from my class. So I developed a model for these students. I trained this model. Now it is time to generalize this model. What is that? When a new student comes in, based on the model that I already developed and trained, can I predict whether this student is going to pass or fail? Can I predict what grade this student is going to take? So the goal is to generalize the model after training. Now there is this discussion among the people, if you took statistics before, what is the difference between statistics and machine learning? All you are trying to tell us is actually already told by statisticians. What is the difference, right? Statistics and statisticians are worried more about explaining why a student passes machine learning, why a student gets 90 from machine learning. So they're trying to establish causality. Machine learning, it's all about prediction. I don't care if there is multiple linearity. I don't care if there is a problem in the model that statisticians are going to point out. All I care is whether my model works efficiently in terms of making predictions. So machine learning is all about making predictions given data set. So this is how a machine learning project actually flows. So the user creates data and somebody collects this data. There are so many different ways of collecting data. We have abundant amount of data, and that's why everybody's talking about machine learning, AI, data analytics now. It's very cheap, and companies need people who are going to deal with these data sets. So once we have the data set, we are going to cleanse this data, which takes 70% of the time when you work on a project. It takes 70% of your time to clean the data set. Cleaning the data set means you prepare the data set put in a format that you can work with. Cleaning and then transforming this data set means there might be a lot of missing data in your data set. Right? So there might be scaling issues in your data set. You have to take care of. After you clean and then make your data set ready to be worked on, it is ready for you. Now you split data set into two. We start from a simple case. Two. Test data set, training data set. So you're going to be using the training data set to create your model. We are going to see in a moment how we split data set and then what training data set does. So we are going to, I'm going back to the example I just gave. So students who took my class, and I know their performance right? So I have that data set. Now I slice that data set into two, assuming data set is clean. So there is 75%, 80% of the data set I put aside. I'm going to be using this data set to train my model, to have a model that will help me to predict a student's performance. Right? And a smaller percentage of the data set, 25%, 20%, it might be 10%, it might be a single data point, given the size of data set. I'm going to put it aside. I'm going to be using this data set as a test data set. So what I will do is, whatever model I created here, I'm going to test this model on this smaller test data set. Because I don't know the label of a new student entering into this class. I don't know what this student will do. So I cannot test my model on this new student because this student did not receive any grade yet. So how can I test my data set? The way is I take the historical data, divide historical data into two, use a portion of the data set which I assign as test data set. So I know the labels, I know the grades of the students in this test data set. I know how the students have been doing. I know the attributes, the vector for each student, right? So given those information about each student, I make the prediction and see how my prediction overlaps with the real label that I already know about. So that is the test. That's how I test my model. Now, of course, the model will not be perfect. We are going to go back and forth to improve the model. Right? So there are certain parameters that at the beginning we don't know which value we should assign to these parameters. So we are going to adjust these parameters to make the model better and better. Right? And then once this model is ready, I deploy the model. So if it is a recommendation system, I deploy it when a customer comes into Netflix. I now recommend movies based on this customer's history or information about this customer. Yes?
So under the data cleansing transformation box, are you referring to testing the quality of that data, the integrity of that data? Is that what you're referring to?
Transformation, I'm referring to, so I have, let's say, age of, I'm just giving an example. I have individuals and information about individuals. One component of this information is age. Another component is, let's say, salary. Now, age will change from, say, 15 to 100. Salary might change from 30K to, say, 250K. So when I run a model, given these two vectors, one vector is age, the other one is salary. Salary is going to be a dominant factor in my model. So I want to, in this case, I'm referring to scaling. Transformation, subset scaling. I need to scale these two vectors so that salary is not going to dominate age, or salary is not going to dominate some other variable, let's say changing between 0 and 1. So I need to transform my data set so that different attributes in the data set, different features in the data set are not going to dominate each other.